Hello and welcome to another rendition of Math is Easy Step by Step. Thank you for joining me today. One important thing that many instructors they don't teach you, it's the invisible ones. Okay? You want to always show all of your invisible ones. This will eliminate a lot of confusion and help you to find clarity when you're working your math problems. So I'm going to try, if I can, to show you some examples of everywhere you'll find these invisible ones. So unless there's a number assigned to these variables, x, y, z, there will always be an invisible 1 in front of that x. You can say, hey, that's 1x. That's 1y, right? Now, this consonant, 3, is obviously that it doesn't need invisible ones. It's 3. But there are some invisible ones here in the exponents place. And there's also an invisible 1 in the denominator's place. Now I use a dot, dot, dot to show you that it's invisible. This is instruction. Can you write a 1 here or a solid 1 in the denominator working these problems? Absolutely you can. It all means the exact same thing. So here in the exponents place, there's an invisible 1 in these variables, x and y, the letters. And these are also terms over 1 unless otherwise indicated with a constant or a number. Okay, so here's some examples below. You want to make sure you're clarifying. If I'm going too fast, please rewind, watch the video again. You want to clarify these invisible ones because many times it will help you in understanding the steps that you need to take. So I show an invisible one here in the exponents place. I also remind myself, hey, there is a 1 in that denominator. And remember, this means 3 times y. You could show it like that with a multiplication symbol in between. Here in this next term, x over 2, and I'll get a little further into this example later, there's a 1 in the exponents place. There's a 1, invisible 1, in front of that x. There is a invisible 1 in that exponents place for a 2. I'm not going to show it, but you could also put I'll show it. There's an invisible 1 underneath that x value. There's an invisible 1 underneath that 2 value. And this really helps when you're dividing with fractions and exponents. Moving on, this example here, the term c to the power of 2, there's an invisible 1 in front of that c. There's an invisible 1 underneath that c. So this really helps to clarify what's going on, especially if you're going to be multiplying terms. You want to multiply coefficients, 1 times 3, 1 times 5. You want to see that. Here, with this term 7, there's an invisible 1 in the exponent's place. Of course, there's an invisible 1 in the denominator's place. And guess what? There's an invisible 1, negative 1, right outside these parentheses. So that's a negative 1. When it comes to distribution property, you want to multiply negative 1 times a positive 7. It really just clarifies what it is that you need to do. Here with this term, there's a negative 1 in front of that x. There's a invisible 1 in the denominator's place. Excuse me, the exponent's place. In the denominator's place, there's a invisible 1 in the exponent's place, and again, an invisible 1 underneath that 2 in the denominator's place. Hey, let's take a look at some more examples I have set up here for you, and understanding invisible 1. So here I wanted to show you with this first example, x over 2. Well, that's really 1 times x over 2, which can be written 1 over 2x, or maybe more commonly, as you see here, 1 half x. All of these mean the exact same thing. You're only clarifying for yourself in order to perform any operation. Let's take a look at some more examples. Here during distribution property, I just mentioned previously, you have a negative outside of the parentheses here. Well, that is a negative invisible 1, right? And there's a 1 in front of that x. Show your invisible ones. It will clarify what you need to do. So that's a negative 1 times 1x using distribution property. That's a negative 1 times 1y. This really is going to help clarify your procedures and your steps on what to do. So again, show those invisible ones. So what does this mean? This means negative 1 times 1x. I'm showing you that here. Separated with a plus sign. You can separate any terms with a plus sign. It's not going to change anything. It's only going to clarify what you're doing. Negative 1 times a positive 1y. You see here, negative 1 times a positive 1x leaves you negative x plus negative 1 times a positive 1y leaves you with a negative y. We were able to simplify this term. And I have one more set of examples I would like to show you. One more example I'd like to show you here. Example number 3. This has to do with a square root. So many times they don't show the square root, and in this case maybe it's an invisible 2, but square roots are left like this, but you could put a 2 up in there. That does mean a square root. So outside of the square root is an invisible 1 I'm showing you here in the next step. And anytime you pull out any values outside of the radical, I kind of call this like a little prison. I want to free up the jailers, the prisoners inside, the terms. Anytime you take anything out, you have to multiply times 1 at invisible 1. And this kind of just helps to clarify. So I'm going to slowly go through this here. We have the square root of 8. Remember that invisible 1 is outside. Show that invisible 1. 8 breaks down to its smallest terms. I'm going to go over this slowly. 4 times 2. And I know 4 can be broken down even further. And remember, if I'm going too fast, come on, go ahead and pause, rewind, do what you need to do, and that will help you understand. Again, 4 is 2 times 2, and then we just bring down the times 2 up here from the 8 original. Remember that invisible 1's on the outside. In order to free up a square root, you need 2 perfect terms. Here, I'm showing you in the next step, there are 2 2's. So I can pull out 1 value. 2 2's, pulling out 1 value. Whatever you pull out outside of the radical, you must multiply times this invisible 1. Or there could be another term, another variable sitting out here. Whatever you pull out of the radical, you must multiply times. If nothing is there, show that invisible 1. It'll help clarify things. Whatever's left inside the radical or the square root, you're going to leave that inside the square root. It doesn't have a partner to pull out 1 value. So you're going to just leave it on the inside there. And as we simplify further, you can see 2 times 1 is 2. We're going to leave that 2 inside the square root. Again, there is no partner to pull out that 1 value. And so we will leave this here as an explanation. I'm not teaching you how to solve radicals manually or cube root inside the radical, but here I'm just going over the invisible 1. So hopefully this has been helpful. Thank you for joining me. Hey, math is easy. Take it step by step.